So good morning, everyone. Thank you so much for being here today. And I'm Arpan Pokhrel. Over the next hour, we are going to explore something that not just trending in tech circles, but is genuinely reshaping how we work, create, and solve problems. We are talking about the AI agents, the future of automation. Now, I know some of you might be thinking that another AI buzzword, but trust me, by the end of this session, you will understand why it is thus the hype. This is the fundamental shift in how intelligent systems operate. As you can see in my slide, today is November 17, 2025, and we are at the inflection point. The race to build an agent is accelerating, and understanding what they are and how they work and when to use them will be crucial for everyone working in technology, business, innovation, or in any of the field. Let's dive in together. Before we jump into agent themselves, let me quickly introduce the platform behind this work, CorelLink. What is CorelLink? So CorelLink is an AI-powered career development platform, and our mission is simple but ambitious. We help individuals future-proof their careers. In a world where AI is changing job descriptions faster than we update our resume, we believe in practical learning, real-world use cases, and expert-led communities. Let me break down what we offer. First, we have the career GPS assessment. Think of this as a compass of your professional journey. It helps to identify your current skills, strength, and most importantly, your AI career path. It doesn't provide only the generic advice, but it is personalized to what you are and where you want to go. Second is AI learning circles, and these are the small expert-led groups where you don't just learn the theory, but you work on real-world problems. Your collaboration is the key. So this is also we are also running currently running a circle, so you can know what is it. Third is real world AI use cases. We explore how the AI is applied across the industry and roles. We provide the curated examples of different industries, healthcare, finance, marketing, operations, so on. You can see how the AI actually applied and not just talked about. Finally, the AI tools and prompt library. We have curated collection of prompt books and the tools that you can use right away. No fluff, just the practical resources. That's the ecosystem we are building at the Korea Link, and today's session on AI agent is exactly the kind of the real world actionable knowledge we want to share with you. Let's talk about why you are really here, and let's look the real world use cases before we dive into the theory. This is important. Before I tell you what the AI agent is, I want to see one in action. So this is our real world use case in Korea Link. Let us imagine you are a customer support for an e-commerce company. Every day, hundreds of email come in and order issues, refund requests, product questions. Traditionally, a human reads each email, decide what action to take, updates the CRM, and response. It will be much more time consuming, right? We all can feel what I'm saying now. So imagine AI agent handling this, and it reads an email, understands the intent, checks the order of the database, and determines whether if it a refund case or not, process the refund, updates the CRM, and sends the personalized response, all without the human intervention. So that's not a science fiction. That's happening today, and this is just one example. I want to ask one question: is how do this agent work, and when should you use them, and how can you build one yourself? We have seen what agents can do. Let's map our journey. Today our agenda, first I'll be giving introduction about the agent. Second, AI architecture and functionality overview. We'll learn different types of agentic system from simple rule based to autonomous one. So third, real world use cases. We'll look actual implementation across the industries, and finally we'll do building your own agent. We'll do one walkthrough. We'll do one practical example. These days, everyone seems to be racing to build agents. Like when we open LinkedIn, Twitter, blogs, everyone is talking about the agents. But pause for a second. Why the world is suddenly obsessed with the AI agent? What changed? Here the thing is, the term AI agent has been around decades in computer science. But what's different now is that we finally have the technology like large language models, advanced reasoning capabilities, tool calling APIs to build agents that actually work at scale. We are not just jumping on a trend, but we are witnessing a technology unlock. Agents are becoming practical, deployable, and valuable nowadays. That's why everyone is paying attention. But before we can build one, we need to understand what makes something an agent. That's what we are unpacking next. Let's define it clearly. AI agent is like a digital assistant that can think, make decisions, and take actions to help you achieve goals. Let me break that down. First, let's distinguish between the two related concepts, generative AI and agentic AI. Generative AI is things like ChatGPT, Midjourney, Copilot, as all of you have been using now, is a great at understanding and generating content. You can ask question, it gives you an answer. You prompt it for an image, it creates one and it responds. But agentic AI it goes for a step further. It does not just understand and generate content, but also it performs certain actions. It can plan, it can decide, and it can execute. Here is an analogy. Generative AI is like having a conversation with a highly knowledgeable friend, while agentic AI is more like hiring an AI assistant who not only advises you to book a meeting, draft an email, and follow up, but can actually take those actions on your behalf. The shift from the generative to agentic AI is the shift from responsive to proactive. That is a huge leap. Let me give you a simple framework to think about this. You can think like here is a like certain model I want you to remember. Imagine three types you could hire, like human assistant. This person needs constant direction. They ask for every decision. Like should I schedule a meeting at 2 p.m. or 3 p.m.? Should I send the email now or later? They are helpful, but they require a lot of hand holding. But AI assistant is this like Siri or Alexa. They respond to specific requests like, hey Siri, set a time for 10 minutes. Alexa, play my workout playlist. They are reactive. You tell them what to do and they do it. No initiative beyond that. An AI agent, this is different. An AI agent can work independently. It can plan multiple steps. It adapts to your changing situations. You give it a goal, like you organize my schedule for next week to maximize work time, and it figures out the rest, or it looks your calendar, finds the meeting, it identifies the meeting conflicts, suggests the reschedules, and even drafts the emails to the participant. You can know the difference, right? Like the AI agent doesn't respond, it thinks ahead and plan and acts. That's autonomy. Let me give you much more relatable analogy, like cooking example. You can see like first a bot or rule-based system. This is like a kitchen robot that follows the exact recipes. You can feed it instructions like chop onions for 5 minutes, add tomato, and stew for 3 minutes. It does exactly like that. But what's the problem is that if you are missing an ingredient, like say you are out of tomatoes, it stop working. It can't adapt and it does not know what to do next. Second, an AI assistant. It is like a helpful cook who can answer your question about recipes. You can ask what's a good substitute for butter, and they say you can use olive oil or coconut. They suggest alternative when asked, but they don't know the initiative and they wait for you to ask. Third, an AI agent. Now this is like skill safe. They understand your diet preferences. Maybe you are gluten free or vegan. They check your pantry to see what you already have. They plan your meals for interweek. They even go shopping and find missing ingredients. And if something isn't available, they adapt recipe on the fly. That skill safe, that's an AI agent. It does not just execute the commands, it understands your goals, makes decisions, and take actions that we are building toward. Let's test your understanding. What I have said up to now, I'll ask some certain questions. Please answer. So I want to play a hands-on activity, one classification game. So I'm going to give you three scenarios, and I want you to think whether it is a bot or AI assistant or an AI agent. And comment down below agentic system and when to use what. We have looked what makes AI agentic. It's not just about understanding or generating content, it's about performing actions and handling tasks end to end. But here is the thing, not all agents are built the same, and not all problems need highly autonomous systems. One of the biggest mistake teams make is over engineering, and they build a fully autonomous agent when simple rule based system also would work just fine, and they try to automate everything when human in the loop workflow would be safer and more reliable. We're going to walk through four types of agentic systems, and I want you to think about this simple but in powerful lens. How much autonomy does the agent have, and how much control does the human or system retain? This is a great question, and this balance between the autonomy and control impacts how the system behaves and how you evaluate it and what infrastructure you need to build. Let's break down each type one by one. So let's start with the simplest rule-based systems. Rule-based systems simply means low autonomy and low control, and these systems don't use large language model at all. They are built with traditional if-then-else logic. Every decision path is manually scripted. There is no reasoning and no learning. But rule-based agents have existed long before LLM era. Think of them as the foundation, the simplest form of automation. If you can solve it without the AI, do not overcomplicate it. So what problems do they solve? It solves the well-structured repetitive tasks with fixed input and outputs. For example, automatically approve the reimbursement under a fixed amount, like rename files in a folder, like copy data from Excel. It is simple, right? It is also incredibly useful. So, what are its pros? It is fast, audible, predictable, and you know what exactly will happen. And cons, brittle to change, can handle the ambiguity. If something unexpected happens, it breaks. So, when to use? You can know all the condition ahead of time. When you know all the condition ahead of time and there is no need of flexibility, you can use this agent at that time. Let's add some intelligence and without giving up the control. That is the workflow agent, and we are going to study that next. Workflow agent, low autonomy and high control. This is often the first step for enterprise introducing the LLM into their workflows, and it makes sense. You get the benefits of AI without taking the big risks. LLM enhances the existing workflow, but it does not execute the action independently. A human stays in the control. So think of like this, like AI suggests and human decides. So what problems do they solve? Repetitive tasks that benefit from natural language understanding, summarization, generation, but also still need the human decision making. Let me give you some examples. Like in a customer support tool like Zendex, an AI suggests first draft responses based on the ticket content. The support agent reviews, edits if needed, and hits send. AI speed of the process, but human makes the final call. Like for example, like generating summaries of the meeting transcript. And AI listens to the meeting, pulls out the key points, creates a summary, and team lead reviews it before sharing to the participants or stakeholders. You can see the patterns. AI does all the heavy lifting, but like understanding, drafting, translating, but it does not act on its own. It needs something human intervention. What are its pros? It is easy to deploy, low risks and quick value. You are augmenting the humans, not replacing them. And cons, you can execute or plan, limited to end-to-end value. You still need the human oversight. But when it is best to use, you can augment your team productivity without giving the oversight. When you need certain human intervention, then these workflow agents are the best. Let's increase the autonomy. Previously, we have increased the work control. Now, let's increase the autonomy and make the semi-autonomous agent. What we are going to study next. What are semi-autonomous agents? It is moderate to high autonomy and it has moderate control. And these are the two agentic systems. They not only just understand the tasks, but they can plan multiple actions, invoke tools, and complete the goals with a minimal supervision. However, they operate with some constraint or monitoring building. You are not giving them unlimited freedom, but you are adding a guide rails or you're defining the guide rails. What problem do they solve? Like multi-step workflows that are well understood but too tedious or time-consuming for humans. But let me walk through you the real examples. One, a lead follow-up in sales. It pulls data from CRM, drafts your personalized email based on the lead profile and behavior, and sends the email and logs the results. It's handling the entire workflow, but within the boundaries we have set. Another example is like a research agent. You can ask it to compare the pricing strategies between three competitor company, and it pulls the data from multiple sources, compares the finding, structures the report, and sends you. When you go move on, that's powerful, right? How is the LLM used here? The LLM plans the steps, it calls the API, pushes the data, it keeps the track of the progress, and if something goes wrong, say an API fails or it adapts and it might retry or it might scale to the human. What are its pros? It automates the complex workflows, saves the significant time, and it has higher return of investment. And what is cons? It needs infrastructure. It needs planning, memory, tool capabilities, and it is harder to test and debug. When it is best to use? When you want to automate the well-bounded business workflows while retaining the some control. With less control, if you want to automate the things, then these agents are the best. And finally, the most advanced fully autonomous agents. So autonomous agents have high autonomy and low control. These agents are fully goal driven. You can give them a broad objective, they figure out what to do, how to do, when to retry, and when to escalate. They act independently, often across the system and over time. This is a cutting edge. It is also one of the most challenging to deploy and build safely. What problem do they solve? High effort, async, or long running tasks that span multiple systems or steps and do not need constant human input. Let me give you multiple examples. A competitive research agent. You set it to lose to monitor your competitors. It pulls the data for overdays, pricing changes, product launches, marketing campaigns. It summarizes the update and generates the weekly insights, and you just review the briefs. And an automation agent, it continuously monitors the data pipelines. It detects an issue, say a pipeline fails, and it diagnoses the root cause, checks the log, files a ticket, and suggests the fixes. It's acting its own 24/7. You can see the leverage. One agent is doing the work of an entire team. How LLM is used here? LLM is everything. It is a planner, is a decision maker, and is a tool user, memory tracker, communicator. It manages the retries, evaluate the goals are met or not, and decides whether to stop or adapt. When to use or what are these pros? It is extremely scalable. can handle complex attacks, high leverage attacks. Its cons are high risks if not monitored properly. Yeah, hard to evaluate or trace what's happening. You need to robust logging or error handling and fallback mechanisms. When it is best to use, when the task is highly leveraged or synchronous and doesn't require human feedback at every step. You have seen the four types of the AI agent. Now I'll decide how to build and how you decide what to build. So let us go to decide how to decide what to build. This is a great question, right? So you don't decide by picking your favorite architecture. You didn't start by saying like, I want to build an autonomous agent because it sounds cool. You start with a problem. I'll be giving a certain framework. This is the four questions you need to ask yourself. Is it repetitive and structured? If yes, you might not need to use an LLM. It is a rule-based system, and rule-based system can easily be worked in a repetitive and structured. If you know the output, if you know the answer, and you know the expected result, so you can use a real rule-based system. Does it involve language understanding on generation? If yes, you are looking for a workflow agent or beyond that. Is it a multi-step task that need decision making? If yes, you need to move in semi-autonomous territory. So do you trust an AI system to execute the entire task? Or do you want an human in the loop? So this question determines your autonomy level. Something important thing I want to share with you. These approaches aren't mutually exclusive. A single system can be mixed with them. Some part might require high control, like approving financial transactions. Other can benefit from high autonomy like data aggregation. Each problem type can be tackled by either a single agent or group of collaborating agents. We'll explore that more in our architecture section, but I want to make you a key takeaway that start with the problem, not the technology. First define what is a problem. Don't start with directly I want to start with big high autonomous agent or what want to build, not the technology. This is kind of much more theory, right? I've been saying theory all the time. Let's build an AI agent. I'm going to walk you through the core architecture decision making process and the key components. And by the end, you'll have one model and some code, and then you will be able to take back and start experimenting with. Every agent operates on a core loop. Let me show you that this is the think, act, and reflect model. This is the heart of how agent process the information. Every effective AI agent operates on a loop: think, act, and reflect. Let me break it down. Think, the agent analyzes the request. It breaks down the problem. It identifies what's needed. It figures out what I'm trying to accomplish and what information do I have and what do I need. In act, the agent executes the decision. It uses tools if necessary. Maybe it calls an API, queries a database, or performs the calculation. Then it generates the response. And reflect. The agent evaluates the results. It asks, did that work? Is the task complete? Do I need to adjust? What's next? What's the next step? This loop can run once or multiple times until the goal is achieved. Think, act, and reflect model isn't just for AI agent. It's actually how we solve problem as humans. You can think about a problem like you take an action, you reflect on an outcome, and you adjust. Agents are doing the same thing, just much faster. This magic happens when the loop runs autonomously and without you needing to guide every step. Let me show you in this action and with a real example. Here is a simple question. What's 47 times 23 and is that even or odd? Let's walk through how an agent processes during this think act reframe model. Think. The agent analyzes the request. It recognizes the two parts, a calculation and a classification. It thinks that this requires calculation first, then analysis. And in act, the agent performs the calculation. 47 times 23 equals to 1081. Then it checks is 1081 even or odd. Then it applies the logic. If a number ends in 1, 3, 5, 7, or 9, it's odd. So 10181 is odd. In reflect part, the agent evaluates the result. It thinks that it can have both answers, the calculation and the classification. The task is complete and I'm ready to respond. So it responds the 47 times 23 equals to 1081, which is an odd number. You can see how the loop worked. Think, act, reflect, respond. It's systematic and it feels natural. So we also think same as our brain takes to process, and we need like certain tools, calculator for processing. Here AI does it much more faster. Imagine this loop running for a complex task like analyzing a customer feedback, categorizing the issues, drafting responses. Same process is just scaling up the tasks. One of the most powerful part of building AI agent is also the system prompt. Let me show you. The system prompt is like a personality chip for your AI agent. It is an instruction you give at the beginning that shapes how the agent behaves, how it responds, and how even it thinks. Let me show you three different system prompt for same underlying AI model and how they create different personalities. So in prompt one, you are a patient math tutor. Explain step by step with examples. If you use this prompt, the agent will break down every calculation, show it work, and use analogies. According to this prompt, this agent will act as a math tutor. In second prompt, you can see that you are a professional email assistant. Be concise and formal. With this prompt, the agent becomes direct, polished, and efficient. It won't ramble, and it will get to the point quickly. In prompt 3, you can see you are a creative storyteller. Be imaginative and engaging. Now the agent becomes expressive, use vivid languages, tells stories. Same AI but completely different output. The system prompt saves the agent's entire personality. And this is one of the easiest way to customize your agent without changing any code. You can just change the instructions. When you build your agent, spend time crafting the system prompt. It matters more than you think. Let's talk about the technical parameters that control how your agent behaves. When you are building an AI agent, there are a few key parameters that you need to understand. Let me walk through the most important ones. First, model. This is which AI you are using. For example, GPT-4. This is the most capable model of OpenAI, based reasoning, based understanding. GPT 3.5 Turbo is faster and cheaper and much less capable. You choose based on your needs. And temperature, this controls the creativity. If you set the temperature to 00, the output is deterministic and focused. The agent will give you same answer every time for the same input. This is great for tasks where you need consistency like data extraction, classification. But if you set your temperature to 0.7, you get a balanced output, same variation but still reasonable. If you set the temperature to 1, the output is creative and varied. The agent will explore different ways to respond. This is useful for brainstorming, creative writing. Think of temperature like this, like a dial, like telephone dial. Previously we used to use. Low temperature, it is most predictable. High temperature means creative. And third are messages. This is the conversation structure. It is an array of objects where each object has a role as a system or user or assistant. And the system message is your instructions. And user message is the input. And the assistant message is the response. These three parameters, model, temperature, and message, are the foundation of every agent you want to build. If you master this, you are 80% of the way there. We have covered the theory part and now is the hands-on time. I want you to take the concept we have discussed like system prompt, think, act, refer, loop, and key parameter and start experimenting. And I'll be providing you collab file and I've made a certain code where I've experimented different and you can also experiment on that code and I'll be running certain code and showing you the results. I've created a simple collab file. You can all try experimenting from here. I built a simple AI agent using the Google Gemini API, and this is a step-by-step notebook, so you can run by step and you see how it is running and how you can experiment using the different temperature parameters and system prompt. Wherever I have also tried to encompass here. Let's initialize the Gemini agent. Before running this, please see this requirement. You need to put Gemini API key in your environment file. Here, you should keep your Gemini API key. And if you don't have Gemini API key, you can create from your Gemini API key and import key from Google AI Studio. So it automatically imports your Gemini API key. Or if it doesn't import, you can directly go to AI Studio and you can see Gemini API key and you can paste here. Let's run one by one. Okay, let's run this first block. This first block or first cell does not do anything, but it just initializes a Gemini client. You can see that I have used Google from to client library, and from Google it had imported Gen AI. So I am just initializing the like Gemini using our API key so that we can use in further access. So this is just a helper utilities. So when we want to print or anything in below, so it just makes us your readable print. So it prints in like this form. We can see when you run, you can see the output, and this is a simple create simple agent function. So what does it do? This simple function is that it takes the user messages, it takes the simple prompt, it takes the model, and I am defaulted to the Gemini 2.5 less, and it takes the temperature of default 0.7. And so default the debug means whether to print the output or each and every step process or not. So you can basically understand that this agent takes the user message, system prompt, model, temperature. Let me go through this code. Simply, if system prompt is none, it builds the system prompt, and simply if this is the defensive argument checks whether this is required, this should be string, or this should be less than one, or this, because it cannot go greater than one. This is according to model we are making the argument check. We have built the config here. So what are the system instruction and what are the in temperature? And if you want to show debug, so I have used the utility function above. So it does a pretty print and what a model, what temperature, on what system prompt, and what user message it provided that output. We can look and debug easily. We have called the Gemini API here using the contents as user message and config as system instruction and temperature, and model as Gemini. We have defaulted to Gemini 2.5 flash. According to this, now Gemini API is initialized here. So we are expecting a result as a JSON. So if there is certain error or certain extraction errors, we have created a fallback to return raw JSON. This is just the initialization of the agent we'll be using further below. Let us create a simple Q&A agent. This is an example one. We'll be simply asking what is the capital of France, and user question is we have been asking that what is capital of France, and we'll be asking the agent. You have been thinking that what system prompt it will use. I have defaulted here system prompt to, you can see that you are an helpful AI assistant. Think step by step before answering. It uses a default system prompt. When we run this agent, you can see that user question is what is the capital of France, and with debug on, it used the model Gemini 2.5 flash with temperature 0.7, and with the system prompt, you are a helpful AI assistant. You think step by step before answering, and user message it gave the answer Paris. So you can see that we have built a simple Q&A agent. Are you excited to go in next agent? So let's build the math tutor agent. Example 2, math tutor agent. So we have built a system prompt here. I have given example previously, so we are using the same system prompt. You are a patient math tutor. Explain concept clearly with examples and with extra instruction. Always show step by step solution and label each step with simple language. Our question is, how do I solve for x into x for plus 5 is equal to 13? Let's see its output. Math tutor agent, we have provided the system from the URL patient math tutor and expect concept clearly with examples, and always show the step by step solution with label each step. Use simple language. So user question is that how do I solve for x into x plus 5 is equal to 13? So it has used the temperature 0 as we need the concise and fixed answer, and model of Gemini 2.5 flash. With that, we can see that agent response is there's a great question. Solving x means we want to get x by all itself. So I want let us see the answer. So it has provided the step by step solution with step 1 what you have done, with step 2 and final answer. We have see the 13 by 13 and you get 4. So it had provided the answer of 4. So according to system prompt, we have made the agent to act as a math tutor. One single LLM we have already used for two types, one for Q&A and the for math tutor. So you can see the power of LLM, and by using LLM we can create a different multiple type of agent. Creative writing agent. You can see the system prompt here. You are a creative storyteller, be imaginative and engaging, and return a story in 3-level paragraph: setup, conflict, and resolution, and keep it under 250 words. When you run this, we have obtained the output. As we need the creative writing, so we have set the temperature to 0.9. You can also analyze this. When we use the mathematics, we have used it 0. So for concise, when you need fixed answer, when you no need to do here and there, we have controlled according to the parameters. You need to define what type of agent you want and what parameters is necessary for that agent. When you need general, we have used 0.7, and when you need specific, we have used 0, and when you need creative, we have used 0.9, or we can use 1 according to your need. When you need study, we need creative. So according to that parameter, we have got the output, proper study output. This is the simple basic agent we have created. As today is just a basic class, in next class we will be learning about the adding tools, memories, and making much more engaging. Today we have just created certain what agents can do and what agents are and what a basic type of agents. Subscribe to our channel and hit the bell icon for more AI contents like these.